Howdy, Mr. Oppenheimer.
Evening, Walt.
What you working on there?
It's classified.
That's what they always say. They think the janitor's too stupid to know anything. You know, I got this job just as any other physicist. If I wanted to, I could have sold all your secrets to the Nazis by now.
Walt, I could have you arrested for even joking about that. Leave me be. I have a lot of work and my mind is muddled.
Your mind's muddled, eh? Well, back in my lab days, it would always help someone to explain things simply. And helps clear your mind. You know what? Tell me about fission.
You want to know about fission? I'll tell you about fission. It all begins with the hydrogen atom. Within this hydrogen atom, we have the nucleus, which is, of course, a positively charged proton. And revolving around that proton is a negatively charged electron. This molecule has the atomic number 1 for 1 proton. Let's say we have another atom of hydrogen. Within this one, again, a positively charged proton and a negatively charged electron revolving. Except this time, within the nucleus is an additional particle, a neutron. Now, the neutron has no charge whatsoever. It does not change the chemical behavior of the molecule in any way. Consider it dead weight. This sort of, atom that has added neutrons into it is what we call isotopes. And this is what we're dealing with. As you go higher and higher on the table of elements, higher atomically, you'll find more protons, more electrons, more complex nucleuses, a greater energy binding that nucleus together, all those neutrons and protons. One such atom, the highest actually that nature can produce, is uranium. So, what we did is a piece of uranium, an atom of uranium, has a very complex nucleus with many neutrons and protons. And this goes against, of course, the symmetry of nature. So it is constantly trying to get rid of those neutrons. This struggle is what's called radioactivity. Are you with me, Walt?
Wait, go back to the...
You see, us scientists have manipulated these pieces of uranium. We have taken a piece of uranium and fired a neutron into it until it's stuck with the molecule to create uranium-239. However, uranium-239 is a malcontent atom. So uranium-239 only remains that way for a fraction of a second. It quickly transfers into, ditching 2 electrons, element number 94, plutonium. That is what we use to build our bomb. Don't tell that to anyone. Now, what we're trying to do is release all that energy that binds all those little nucleus, protons, and neutrons. We're trying to break those apart and release that energy. So what we do is we take an additional neutron and we fire it like a gun into there, trying to split in half the atom, the nucleus, hoping to release all that energy, as well as release all the neutrons within the nucleus and have them crash into other atoms, causing a chain reaction, a great explosion. The problem, Walt, is that it's not working. You see, when we fire a neutron, it just bounces off. All the neutrons scatter, not into each other, they just scatter everywhere into space. We need them to scatter into each other to create the chain reaction. Unless... Of course, if the piece of plutonium were spherical, then we fire the neutrons in the center of the sphere, they would have no choice but to bounce into each other inside the sphere if we close the sphere. Walt, I've done it! I've solved it!
What? Is it time to go already?
I've solved the piece! I've solved the missing puzzle! I've got to go to a meeting! I've got to tell my brother about this!
Well, brother, let's hope your theory is correct.
Yes, let's.
5, 4, 3, 2, 1.
Oh my goodness, brother, I can't even put words in. Oh my God. Oh.
I am become death, destroyer of worlds. Thank you, thank you. You're all far too kind.
Wow. An honor to meet you. You have obtained great. You have achieved what others thought was impossible.
Thank you.
You have obtained great power, my friend. But not as you have great power, what will you do with it?
I will do what should have been done long ago. I will end the war.
How can I say